Welcome back, friends. In this lecture, we are going to see an example of how to perform operator precedence parsing. So these are our production rule. So non-terminal E tends to non-terminal E, terminal plus, then non-terminal T or non-terminal T, then non-terminal T tends to non-terminal T, terminal star. The star is a multiplication symbol here, asterisk. Then non-terminal F or non-terminal F. Non-terminal F tends to open parenthesis. This is a terminal symbol and close parenthesis is a terminal symbol. In between that, a non-terminal E is there and or a non-terminal, terminal ID. So first step is we have to identify whether this particular grammar is an operator grammar or not. So in order to identify that, two rules are there. The rule one is we have to check whether any epsilon production is present in the right hand side of the production rule. There is no epsilon production on the right hand side of the production rule. So first rule not obeys here. And the second thing, we have to check whether any two adjacent non-terminals are present in the right hand side. That rule is also not applicable here because there is no adjacent two non-terminals. We are having a terminal in between these two non-terminals for the first two production rules, and then the third production rule, the non-terminal is present in between the terminals. So there is no adjacent two non-terminal in the right hand side. So the given grammar is a operator grammar. The next step is to identify the leading position, that is computation of leading. So we have to identify the leading position for all the non-terminals. What are all the non-terminals present here? One is non-terminal E, another one is non-terminal T, and another one is non-terminal F. So we have seen a set of rules for computation of leading as well as the computation of trailing. So by keeping those rules in our mind, so we have computed the leading of E, leading of T, and leading of F. By generally speaking, a simple method in order to identify the leading position of a non-terminal, you go to the right hand side of your production rule, just see where the non-terminal is present. So we are going to identify the leading of E. So leading of E is present here. So immediately so you have to check which terminal is present immediately or which terminal is present as a first terminal element of the production rule. Okay, so you see here we are going to identify leading of E. Leading of E is present in this right hand side production rule, in the first production rule. After that, a terminal is coming. So that will be mentioned as a leading position. This is A position. So plus, comma. What is another production rule for E? E tends to T. So now we have to check the leading of T. So the production rule for T is T tends to T star F. So here star is a terminal. So that should be included here. Okay. Now what is the another production rule for T? T tends to F. So F is have a separate production, two production rules. One is this open parenthesis E, close parenthesis, and ID. So when you are seeing the first production rule for F tends to this open parenthesis is a terminal. So that is included along with the ID. So this is how we can compute leading of E. So leading of T means, so you see the second production rule, T tends to T star F. So the star will be in the leading position because as per the production rule, as per the rule, so we have seen that A tends to a production rule, A tends to, so see here, A tends to X, A, Y. So if your production rule is in this form, this A will be in this A will be in the leading of A. So here A is, you see here, X, A and Y, this is A. So this A will be in the leading of A. So that's why I mentioned as star, comma. What is another production rule for T? T tends to F. So we have to expand F. So F tends to this thing open parenthesis, E, close parenthesis, or ID. So this A will be in the leading position, comma, this is another one terminal and IV has been mentioned. So next thing is leading of F. So leading of F equal to, so what is the first terminal? So this is the first terminal, then these are the two terminals that will be mentioned in leading of F. So this is how we can compute the leading position. So now coming to the trailing position, computation of trailing. So trailing of E equal to, again, so you see here in the right hand side, so we are going to compute the trailing function for the start symbol E. So what will be the right hand side? E is present here. So what is the terminal present on the right hand side? For the E production, only terminal is plus. So we can include this. So this is the A position. Okay. This is the A position. So we are including plus, comma. The next thing is E can be expanded to another production rule for E is E tends to T. So you have to expand T tends to T star F. Now star is the terminal here that is included. And another one production for T is T tends to F. So F tends to open parenthesis E, close parenthesis or ID. So you see here two terminals are here. For F, two terminals are here. Now which terminal to be selected? So at this case, you have to go to the right end of that production. You have to go to the right end of that production. From the right end, which appears as the first terminal. From the right end, when you are traversing back to the left end, which terminal appears to the first? So the terminal appears to be first is close parenthesis that has been included. Okay. Then comma, only one production rule, only one terminal is there for this production rule for F tends to ID. So that is mentioned here. Okay. The next thing is trailing of F. So trailing of F equal to, again, same thing for two production rules are there. This is the right end production, sorry, two non-terminals are there. In the among these two non-terminals, right, this open close parenthesis is the right end terminal that has been included, comma ID. So this is how we can compute leading and trailing. Students, I hope you can understand the computation of leading and trailing. Thank you.